Let's discuss corrosion and its control. Now we will see various different methods by which we can prevent a metal from undergoing corrosion. This is very important. We have different methods to prevent a metal from undergoing corrosion, that is design and selection of materials. So in this, which best materials that we can select for the fabrication, how the designing of the fabrication can be done, that plays a very important role in the prevention of metal from undergoing corrosion. Then we have applying protective coatings on the surface of the metal. When you apply a protective coating on the surface of the metal, then the metal will not be exposed to the environment and thus it will not undergo corrosion. When it is not getting exposed to the environment, then there is no question of undergoing corrosion. In the case of applying protective coatings on the surface of the metal, we have two different types: inorganic coatings and organic coatings. As we all know, organic coatings is nothing but applying of paints and enamels on the surface of the metal. When you apply paint and enamel on the surface of the metal, the base metal which is lying below that paint will not be exposed to the environment and thus it will not undergo corrosion. In the case of inorganic coatings, we have two different methods. One is metal coating, another one is surface conversion coating. As the name indicates, metal coating is nothing but to prevent a metal from undergoing corrosion, another metal layer will be coated on its surface. To prevent a metal from undergoing corrosion, another metal layer will be coated on its surface. When another metal layer is coated, the base metal which you want to protect will not be exposed to the environment and thus it will not undergo corrosion. In metal coating, we are having two different types again: anodic metal coating and cathodic metal coating. As the name indicates, anodic metal coating is nothing but the base metal which you want to protect will be coated with another layer and that metal will be having lower electrode potential value than the base metal. In the case of cathodic metal coating, the coating metal will be cathodic in nature, means it will have higher electrode potential value than the base metal to be protected. So we have anodic metal coating and cathodic metal coating in the case of metal coatings. Galvanizing is the example for anodic metal coating and tinning is the example for cathodic metal coating. What is galvanizing and what is tinning, I will discuss in the upcoming slides. In surface conversion coating, what actually they are doing is, the surface of the metal to be protected will be converted into its respective compound and that compound will act as a protective covering on the surface of the metal. Thus it will not undergo further corrosion. In this, the most commonly used methods are anodizing and phosphating. We'll discuss about these in the upcoming slides. In addition to all these different methods of corrosion control, we have one more very important one, that is cathodic protection. In this cathodic protection, again we are having two different methods. One is sacrificial anode method and another one is impressed current method. Now we will discuss anodic metal coating in detail. Anodic metal coating is nothing but to protect the base metal from undergoing corrosion. Another metal layer will be deposited and that metal will be having lower electrode potential value than the base metal. So in that case, the coating metal will be anodic in nature, it will undergo corrosion, whereas your base metal remains unaffected. So here we have one example, that is galvanizing. Galvanizing is nothing but coating of zinc on iron. coating of zinc on iron, we call it as galvanizing, and the resulting iron is called as galvanized iron. In short, we call it as GI. You might have heard about GI pipes, which is nothing but galvanized iron. So in this, I have shown a diagram. You can see a grey colored metal. I have mentioned it as Fe, that is iron, and on that a green colored zinc metal layer will be deposited. As we all know, in order to protect this iron from undergoing corrosion, a layer of zinc will be deposited. When you deposit a layer of zinc on the surface of the iron, as iron is having higher electropotential value, it acts as cathode, and the coating metal, that is zinc, it is having lower electropotential value, so it acts as anode here. Since a layer of zinc is deposited on the surface of the iron, as zinc acts as anode, it will undergo corrosion, whereas iron, which is lying below that, it will be protected because it will be acting as a cathode. As long as a small layer of zinc is still there, as long as a small part of zinc is still there, nothing will happen to the iron. Iron will start to undergo corrosion only after a complete destruction of the zinc takes place. So till then, nothing will happen to the iron. This is how, by doing galvanization of iron, we can protect it from undergoing corrosion. How this galvanization process is done? It's a very simple method by which a layer of zinc will be deposited on the surface of the iron. The iron sheet which you want to protect from undergoing corrosion, first it has to be pre-treated. Pre-treated means first the surface of the iron should be treated with an organic solvent. By doing so, whatever the organic impurities are present on the surface of that iron, say for example, if any oil content is there or if any grease content is there on the surface of that iron, it will be completely removed. After treating with organic solvents, then the surface of that iron sheet has to be treated with dilute H2SO4. By treating with dilute H2SO4, if at all any inorganic impurities are present on the surface of the iron sheet, that is if any loose rust is there or if any oxide scale is there on the surface of the iron, that will be completely washed away. So after treating with dilute H2SO4, we have to rinse it with the distilled water. After rinsing it, then the surface of that iron sheet, which is now free from organic impurities as well as inorganic impurities, it has to be then treated with an aqueous solution of ammonium chloride and zinc chloride. By treating with aqueous solution of ammonium chloride and zinc chloride, the adhesion property of that iron sheet will be enhanced, because after depositing a layer of zinc, it has to be adhered to the surface of that iron sheet. So that adhesion property will be enhanced by treating with an aqueous solution of ammonium chloride and zinc chloride. These three steps together we call it as pre-treatment. After the pre-treatment is over, this pre-treated iron sheet, then it has to be dipped in molten zinc. Molten zinc is nothing but liquid zinc. The pre-treated iron sheet, when it is dipped in the molten zinc, a layer of zinc will be developed on the surface of that iron sheet. If excess amount of zinc has been deposited on the surface of iron, then that excess amount of zinc can be removed by wiping or passing between the rollers or passing the blast of air. With a large amount of force, when air is passed on the surface of that iron with a layer of zinc, excess amount of zinc will be removed. And then take it out, and after you can use it for various applications. Here I have given some examples wherein you can find the galvanized iron being used. The best examples that we see in our daily life is roofing sheet. So all the roofing sheets you might have observed, and they will stay up to more than 20-25 years. Nothing will happen to that because the roofing sheets are made up of galvanized iron. Commonly used nuts, bolts, screws, buckets, fencing wires, so all these are made up of galvanized iron. That is, the base metal will be iron, and on that a layer of zinc will be coated. As long as zinc is there on the surface of iron, nothing will happen to that iron. This is how galvanized iron plays a very important role in preventing a metal from preventing iron specifically from undergoing corrosion. Now we will see cathodic metal coating. So in this case, the metal to be protected will be coated with a layer of another metal, and that coating metal will be having higher electrode potential value. So in this case, the base metal which you want to protect from undergoing corrosion will be acting as anode, and the coating metal will be acting as cathode. So interestingly, since the coating metal will be acting as cathode, it will not allow the base metal from getting exposed to the environment. Just as long as the coating metal will be there, nothing will happen to the base metal. This is the technique, or this is the principle behind cathodic metal coating. So in this case, we have one example, that is tinning. Tinning is nothing but coating of tin on iron. On the surface of iron, a layer of tin will be deposited, and that process we call it as tinning. I have shown in the diagram, the grey colored metal surface is nothing but iron, and on the surface of that metal or on that iron, a layer of tin will be deposited. So in this case, iron, it is having lower electropotential value, tin is having higher electropotential value. So therefore iron will act as anode and tin will act as cathode. Since cathode is deposited on the surface of the iron, as we want to protect iron from undergoing corrosion, iron will not be exposed to the environment because tin will act as a protective covering on the surface of this iron. So as long as complete layer of tin is there on the surface of iron, iron will be safe. If small rupture happens on the surface of that tin, then the base metal, that is iron, will be exposed to the environment and it will start to undergo corrosion. We might have seen in the case of factors affecting rate of corrosion, ratio of anodic to cathodic area. When the rupture of tin, small portion of the tin get ruptured, then the small anodic area will be exposed to the environment and it will undergo corrosion at a much rapid rate. This is how tinning actually plays a very important role here. If coating is done properly, then it will protect iron from undergoing corrosion. If coating is not done properly, then it will be disastrous. Now we will see how the process of tinning takes place. It is exactly similar to what we have discussed in the previous slides, that is galvanizing. First 3 steps will be similar, that is pre-treatment of the iron sheet will be taking place, that is treating with organic solvents, followed by treating with dilute sulfuric acid, then rinsing with water, and then followed by again treating with aqueous solution of ammonium chloride and zinc chloride. After the pre-treatment is over, then the pre-treated iron sheet will be dipped in a molten tin. So after dipping it in a molten tin, a layer of tin will be developed on the surface of that iron sheet. If excess amount of tin has been deposited, then it can be wiped off, rubbed off, or then by passing a blast of air, we can remove the excess of tin. So usually tin coated iron sheet will be utilized for storing food. So various food storing utensils are made up of tin coated iron. So here one interesting point that we have to observe here is, so I will ask you one question: which process is better, whether galvanization is better or tinning is better? I want you to answer that. Which process is better? Galvanization is better or tinning is better? Next method of protecting a metal from undergoing corrosion is cathodic protection. This is very important as per the prevention of metal from undergoing corrosion is concerned. So far we have seen that during a metal will be undergoing a corrosion, the flow of electrons will be from anodic area to the cathodic area. In the process of corrosion, the flow of electrons will be from anodic region to the cathodic region. The very basic principle of cathodic protection is to protect a metal from undergoing corrosion, we have to reverse the flow of electrons. That is, instead of making electrons to give out the electrons, we have to make it to accept the electrons. If it accepts the electrons, then it will be acting as a cathode and it will remain unaffected. This is the principle of cathodic protection. To define, cathodic protection is a technique used to protect a metal against corrosion by providing electrons to it from an external source. When we provide electrons from an external source to our desired metal, then that metal acts as cathode and it remains unaffected. This is what the principle of cathodic protection is. So in this cathodic protection, we have two different methods. One is sacrificial anode method and another one is impressed current method. So as the name indicates, sacrificial anode method. So in this method, the structure to be protected, it has to be connected through an insulated copper wire to sacrificial anode. Means the structure to be protected, it has to be connected to another metal which is anodic in nature. Means it has to have lower electropotential value. So in this picture I have shown the example of the structure to be protected as iron pipe, and this iron pipe is connected through an insulated copper wire to sacrificial anode, that is zinc. Since zinc is having lower electropotential value, it will act as anode and the structure to be protected, that will act as cathode. Since zinc is acting as anode, it gives out electrons, and these electrons, they travel through the insulated copper wire and then they will be accepted by the iron pipe. Since iron pipe accepts electrons, it will act as cathode and it will remain unaffected. Nothing will happen to the iron pipeline. Whereas this zinc, since it is acting as anode, slowly it will start to undergo corrosion and ultimately it gets destroyed. So in order to protect this iron pipe from undergoing corrosion, zinc has destroyed itself. It has sacrificed itself, hence the name they have given it as sacrificial anode method. Another method of cathodic protection is impressed current method. This is also similar to that of sacrificial anode method, but in this case inert anodes are used. Inert anodes like graphite, platinum, platinized titanium are used as anodes here, and the structure to be protected, that will be acting as a cathode. And the only difference here is these anodes and cathodes, they are connected together by a DC power supply. So usually the impressed current method of protecting a metal from undergoing corrosion will be carried out for large structures to be protected. So here the inert anodes like graphite, for example, will be connected to the positive terminal of the DC source, and the negative terminal of the DC source will be connected to the structure to be protected. So the electrons will be flowing from the graphite or the anode and they will be moving towards the protected structure. Thus the protected structure will be acting as cathode and it will remain unaffected. And since these are the inert anodes, nothing will happen to these anodes also. So in order to protect the huge structures, this impressed current method plays a very important role. So as per cathodic protection is concerned, may it be sacrificial anode method or impressed current method, so this type of preventive measures or prevention method is commonly used to protect the structures, for example underground pipelines, underground oil pipelines, water pipelines, marine structures. So all these can be protected by using these particular methods, may it be sacrificial anode method or impressed current method. Now we will discuss the last method of corrosion control, that is surface conversion coating. So in the case of surface conversion coating, the surface of the metal to be protected will be converted to its respective compound, and that compound will act as a protective coating on the surface of the metal. So in this case we have the example of anodizing. Anodizing is nothing but anodic oxidation. It is a process of conversion of base metal into an anode and depositing a layer of its oxide on the surface. See how interesting it is. So far we have discussed that anodic part of the metal will be undergoing corrosion. But in this case we are discussing about corrosion control methods, and we are saying that to protect the metal from undergoing corrosion, we have to convert it into an anode. Yes, anodizing is nothing but converting the base metal into an anode, and then a layer of oxide will be deposited on its surface. Now we will discuss how actually anodization will be carried out. So usually for commercial purpose, non-ferrous metals like aluminium will be subjected for anodization. Aluminium is commonly used for the anodization process. So we will discuss how anodization of aluminium will be carried out. You can see in the diagram, we call it as a plating bath. In this plating bath, the aluminium article which is to be anodized is made as anode by connecting it to the positive terminal of the DC source, and lead is usually used as cathode, and then the electrolyte is made up of 5 to 10% chromic acid or sulfuric acid. The purpose of using the electrolyte here is to enhance the conductivity of the medium. So apart from this, a moderate pH is maintained and the temperature of about 30 to 35 degrees centigrade is also maintained. When the anodization process is carried out, at that time what happens? The aluminium article which is to be anodized is converted into its oxide, that is aluminium oxide, and that aluminium oxide layer, it gets deposited on the surface of that aluminium article. Once an aluminium oxide layer is deposited on the surface of the article, after obtaining a suitable thickness, then the anodization process is stopped, and then we have to take out that article, and then it is completely dried, and after drying it, it is dipped in a suitable coloring agent for about 20 minutes, and after obtaining a desired color which looks very attractive on the surface of that anodized aluminium, then it can be used for various applications. The technique is very simple. The aluminium article to be anodized is made as anode and it is connected to the positive terminal of the DC source, and lead is usually used as cathode and it is connected to the negative terminal, and the electrolyte is made up of 5 to 10% chromic acid or sulfuric acid. When you apply the potential, when you supply the electric current, the aluminium article gets anodized, that is, whatever the aluminium is there, it gets converted into aluminium oxide. You might see the reaction there. Aluminium reacts with water and gets converted into aluminium oxide, and hydrogen gas will be liberated from the cathodic surface. And this aluminium oxide, it gets deposited over the surface of that aluminium article. By discussing about the factors affecting rate of corrosion, in that we have seen nature of corrosion product. The aluminium oxide which is deposited on the surface of this aluminium article, this aluminium oxide, it acts as a protective covering on the surface of the aluminium. Thus, when aluminium is deposited by a layer of its oxide on its surface, then that aluminium article will not undergo corrosion at all. And by the deposition of aluminium oxide on its surface, the surface of the aluminium looks very attractive. Hence, it has a very wide range of applications in the market. It can be used in various scientific instruments, it can be used in surgical instruments, it can be used in spacecrafts. You might have seen the escalators. Even the escalators are also made up of anodized aluminium. In addition to that, various exteriors of the building are also nowadays made up of anodized aluminium. Apart from these applications, nowadays almost all the cell phones are having aluminium as a unibody covering case. It will not just be any aluminium, it will be an aluminium oxide layer will be deposited on the aluminium. So anodized aluminium are being used as a unibody covering case of various cell phones. First it was being introduced by Apple. Apple mobile phones, they were made up of anodized aluminum as their covering case. Nowadays, almost all cell phones, they are made up of anodized aluminum. So, anodizing is nothing but it is a process of conversion of base metal as anode and depositing a layer of oxide on its surface. So, this oxide layer, it acts as a protective covering on the surface of that base metal. Usually, for commercial purpose, aluminum will be anodized. So, anodization of aluminum can be done by depositing a layer of aluminum oxide on its surface, and then after obtaining a desired thickness, stop the anodization process, take it out and use it for various applications after applying a suitable coloring agent on its surface. You can see various applications of anodized aluminum. In the exterior, sheets are made up of anodized aluminum. Unibody covering case of many cell phones, especially Apple iPhones, they are made up of anodized aluminum. And our very own prestige cooker, it is also made up of hard anodized aluminum.